Okay, here is a video about how to find the charges of an ion. Or how to find the charge of an ion, I guess. So, there are three types of ions that you will typically need to find charges for. Regular ions that are single atoms, polyatomic ions, which are a bunch of atoms stapled together, bonded together in a way that they can't separate, and transition metals, which are these down here in the D block, and some other ones, but mostly these here in the D block. So first, let's start with the regular atoms. They're pretty easy, regular. There are two ways you can do it. One way is to memorize based on where they are at the table. Everything in this column right here is going to end up with a positive 1 charge. These are all going to have positive 2. You're going to skip the D block, they do something else, so skip these. These are mostly going to be positive 3. Now on the other side, you have this. These are all 0, for reasons I'll explain really quickly later. These are negative 1, negative 2, negative 3, and then this particular column right here, these you're not going to have to worry about because they could be positive 4 or they could be negative 4. But on your test, you're not going to have to care about it. So don't worry about this block in the middle. So 1, 2, 3, 0, negative 1, negative 2, negative 3. What that means is that if I want to know the charge of, say, calcium, I have calcium, I find it, calcium is right here, and it's in the 2 plus column. That means that whenever calcium makes an ion, the ion will be 2 plus. To show you one of the negative one, I'll say that I want to know what nitrogen makes, right? Nitrogen is in this column, and this column typically is going to make minus 3 charges. So if I want to know the charge of a nitrogen ion, or nitride, because it's negative, it's going to be minus 3. Regular is easy. You got to either memorize this, or you can use the dots method. So to do the dots method, you need to know how many valence electrons they have, but that's it. Let's say I want to know the charge of sulfur. I draw a picture of sulfur, S. I know how many valence electrons it has. It has 1, 2, 3, 4, 5, 6. So I draw 1, 2, 3, 4, 5, 6. And I say, how can sulfur get to 8? That's where it wants to be. It wants to be at 8. So it gets to 8 by getting 1, 2. Sulfur will gain 2 electrons. When you gain an electron, you become more negative. Think of electrons like problems or like debt. When you get an electron, when you gain a problem, your life is more negative. So sulfur gains 2 electrons, which means that it is minus 2. If I have something on this side, a positive ion, like maybe calcium, right? I'm going to draw calcium, Ca. It has 2 valence electrons, 1, 2, and it wants to get to 8. Now, remember that when something has no valence electrons drawn on it, like when it looks like this, Ca with nothing on it, sorry, I just had to draw a picture. So I draw Ca with 2 dots on it like this, right? But really, calcium, it has 20 electrons. It doesn't only have 2. It only has 2 valence electrons. So it has 2 that are on the outside, and then hidden inside this, right here, are tons of other ones. In fact, there's another shell of electrons right inside, like this. So for calcium, if it loses this, there should be 2. If it loses these 2 red electrons, these 2 valence electrons right now, it'll lose this one, it'll lose this one. Now the inner 8, the inner octet, is suddenly revealed. Now it has 8 valence electrons. So, like this, right? I draw calcium like this with 2, and it's easier for it to lose these 2 outer electrons and reveal its inner octet than it is to gain a ton more, than to gain 1, 2, 3, 4, 5, 6. That'd take forever, right? So what calcium does is it has 2. It wants to get to 8 or 0, because 0 is the same as 8. It wants to lose this and lose this. So now this calcium has lost 2 electrons. It's plus 2. You can draw the dots, figure out how it would be, or how many you'd have to gain or lose to get to 8 or 0, and that'll tell you the charge of the whole column. So that'll all be positive 2. This will all be negative 2. This does mean that the noble gases, like neon right here, neon's got 1, 2, 3, 4, 5, 6, 7, 8. They don't have to gain or lose anything. They don't really do anything. So to figure out the charges of normal compounds, you can either memorize it on the table, or you can use the dots method to figure out how many it'll lose or gain to get to 8 or 0. Check. Next, polyatomic. A polyatomic ion, you just got to look up. You have a chart. This chart, specifically, right here. So if I say, what is the charge of ammonium? So I got ammonium. What's the charge? I look it up. And they say, oh, here it is. It's positive. And if we don't have a number, it's a 1 because chemists are lazy. So NH4 is a positive 1 charge. If I want to know what the charge of, let's see, cyanide is, it's negative 1. The charge of chromate, negative 2. Charge of perchlorate, negative 1. You just look it up. So polyatomic charges, you never figure out. You always just look up. Check. Next, transition metals. The transition metals are these right here. Transition town. Now, I don't have to tell you which version of a carbon I'm dealing with, because there's only one version of a phosphorus I'm dealing with, because there's only one version of a phosphorus or something, right? So let's say you're not in transition town like phosphorus. this is 0, -1, -2, -3. Phosphorus is -3. But if I have something in transition town, maybe like iron, you don't know what I'm talking about. The reason why is because in the phosphorus family, there's only one kid. You have phosphorus, that is -3, my bad. This is the only phosphorus kid there is. But if you're talking about iron, in the iron family, you have a lot more than just the one. You have this iron +1. You also have this one, +2. Both versions exist. You have this, +3. You have this, +4. So what am I going to do if I have so many different versions? The way it works is if I'm talking about iron, I have to tell you which version. There's no way for you to tell. So when I say iron, I would have to say something like iron 3. This 3 would let me know that I'm talking about this particular iron. Or let's say I had this one instead, right? I want to talk about this child of the iron family. I wouldn't say iron 3, not the third one. I'd say iron 2, second one, that one. This is not necessary for non-transition metals because they only have one kid in the family. So if I say that phosphorus kid, it's like I'm saying that Smith kid. There's only one Smith kid. But if I say that Macon kid, there are 4 Macon kids, right? So I don't know which one there is. I got to tell you the second Macon kid, this one, or the third one, that one. So as a quick example, if I wanted to know the charge of, what else is a transition? Right here, chromium, right? I would have to say not chromium, but I would have to say give me the charge of chromium 4. Okay, so chromium 4, for example, would be Cr. And then, I don't know which version of chromium it is just from this, but this tells me that it is the 4th chromium kid, chromium with the 4 positive. Nickel 3, well, that's nickel. And this tells me that it's the 3rd version of nickel, 3 plus. Copper 2, well, that tells me it's the 2nd version of copper. Copper 2 plus. Whenever you have a transition metal, you always will have a parentheses number like this telling you which one of the transition metals you're dealing with, which version, meaning which positive or negative charge. Hope that was helpful.